At 05:12 on October 14, 1943, over the cold, gray skies near Schweinfurt, the air shuddered beneath the thunder of American B-17s pushing deep into Bavaria. Frost clung to the bombers' noses as pilots steadied trembling controls, the formation slicing forward like a steel tide. Then the sun's glare shifted, revealing dark specks diving with murderous intent, German fighters descending in perfect attack lines, certain they were about to tear apart another formation of supposedly unskilled American crews. That confidence came straight from Berlin, where propaganda offices had spent years insisting that U.S. pilots were clumsy, unimaginative, and hopeless without numerical advantage. But within seconds of the first attack run, it became clear that the picture painted by Joseph Goebbels' ministry was a dangerous illusion. The moment the FW-190s slashed through the bomber stream, German pilots realized something was wrong. The defensive fire was too calm, too coordinated. The escorts, though briefly separated, returned with startling speed, diving with practiced aggression. A recollection drawn from post-battle interviews describes a young Luftwaffe wingman stunned as P-47 Thunderbolts rolled through his formation with timing no briefing ever warned us about. Everything he had been taught, every lecture dismissing American flying skill, felt suddenly unmoored. Above Franconia, the sky erupted into a spiraling maze of smoke, contrails, cannon flashes, and twisting aircraft. English and German voices bled together across crowded radio channels. Pilots fought blind through drifting vapor as engines roared like wounded beasts. Yet amid this chaos, American formations held cohesion longer than German tacticians believed possible. After-action summaries filed by U.S. commanders credited the discipline drilled into crews by instructors at stateside schools, where advanced simulators designed by innovators like Edwin Link taught cadets to fly instruments, maintain spacing, and execute defensive turns under crushing mental pressure. This collision between myth and reality had been building for months. By late 1943, the air war over Europe was no longer a contest of individual aces. It had become a test of doctrine, training, and industrial stamina. Under Generals Ira Eaker and Karl Spaatz, the United States committed to daylight strategic bombing, a strategy requiring pilots who could fly long hours through black flak clouds and concentrated fighter screens. Training syllabi emphasized resilience, long simulation hours, gunnery drills, formation endurance flights, and standardized emergency procedures. Meanwhile, Germany, bled on the Eastern Front and pressured in the Mediterranean, shortened pilot training cycles, giving new aviators fewer flight hours and less mentorship from seasoned veterans. Yet German propaganda insisted superiority remained untouched. Newspapers and newsreels mocked American pilots as factory-made amateurs. But within the Reich Air Ministry, internal memos painted a starkly different picture. Reports compiled from frontline units warned of steadily improving enemy pilot proficiency, and intelligence officers noted increasing tactical flexibility among U.S. escorts. Still, these warnings were drowned beneath the louder, comforting narrative broadcast to the public and repeated in fighter briefings across occupied Europe. Behind every American pilot rolling into a dive was a vast industrial and engineering network that Germany grossly underestimated. Factories like Republic, North American Aviation, and Boeing worked in continuous feedback loops with air combat evaluation boards, refining cockpit visibility, engine reliability, and control response. Metallurgists developed alloys for engines built by Pratt & Whitney and Allison, while draftsmen adjusted wing profiles based on wind tunnel tests. Maintenance crews across England rebuilt engines overnight and recalibrated gun sights with mathematical precision. Berlin saw the aircraft and the pilot, but not the massive, disciplined ecosystem that made both formidable. As summer turned to autumn, Luftwaffe interrogators began noticing troubling patterns. American pilots captured after raids demonstrated not only strong flight fundamentals but deep understanding of formation tactics, energy management, and emergency maneuvering. Flight instructors back home had drilled these skills relentlessly, often citing combat data from earlier missions. This loop of adaptation was something Germany, stretched thin and losing experienced instructors to frontline losses, struggled to match. During the final minutes of the Schweinfurt battle, even German ground controllers monitoring from posts near Kassel expressed surprise in internal logs at the advanced maneuver discipline of American fighters. Escorts returning from fuel-limited operations refused to break off the fight as early as expected. An account from a Luftwaffe squadron adjutant described disbelief spreading through his command post as reports arrived of American fighters appearing where no remaining fuel should allow them to be. At midday, the sky over central Germany was scarred with burning engines, drifting parachutes, and broken aircraft tumbling through smoke-stained clouds. Both sides suffered, but beneath the wreckage lay a deeper truth. Germany's assumptions about American pilot skill had collapsed. Training, engineering, industry, and doctrine had merged into a single, evolving force one propaganda had failed to anticipate. In the days following the raid, Luftwaffe intelligence officers scrambled to explain how their predictions had been so catastrophically wrong. The answer they uncovered pointed toward a secret advantage, forged across continents, that Germany had overlooked from the start, an advantage that was only beginning to reveal its full power. And what they discovered next would shift the entire course of the air war. The secret advantage that confounded the Luftwaffe in 1943 did not arrive in a single moment of revelation. It had been building quietly for years in workshops, laboratories, and training fields scattered across the United States. While German planners clung to the notion that American air power relied primarily on quantity, U.S. engineers and tacticians were weaving something far more potent into the fabric of their efforts, an increasingly sophisticated integration of pilot training, long-range escort development, and data-driven tactical evolution. Reports circulating within Allied headquarters noted consistent improvements in gunnery accuracy, climb discipline, and fuel management, skills refined through a system that treated aviation as both a science and an art. The advantage began with training. American cadets received an unusual mixture of academic rigor and practical instruction, beginning with hours inside linked trainers whose vacuum-driven controls allowed students to master blind flying long before they touched frontline aircraft. Reports filed by instructors noted how these machines hardened reaction times and ingrained instincts during simulated battle dives and instrument failures, creating pilots who could stay composed inside clouds of flak. Luftwaffe interrogators later commented on this steadiness when questioning down flyers, surprised by their methodical descriptions of formation tactics and emergency maneuvers. German planning papers rarely accounted for this depth. They assumed American pilots would break apart under pressure, yet training alone could not explain the rapid shift in the air war. The real turning point emerged from engineering teams working to solve a crippling strategic problem: the limited range of fighter escorts. German analysts believed the 8th Air Force would remain tied to a predictable pattern: fighters turning back near the Rhine, bombers forced to endure the deadliest stretches alone. That belief shaped German strategy, reinforced by evaluations circulated within the Luftwaffe command staff. But American engineers, drawing on wind tunnel experiments and engine stress tests, were preparing solutions that would render those assumptions dangerously outdated. Their work produced the drop tank, a lightweight shell of fuel capacity mounted beneath wings or fuselages, enabling fighters to stay with bombers deeper into Europe. Meanwhile, manufacturing plants in the United States learned to collapse production bottlenecks through assembly innovations inspired by automotive giants. Factories at Inglewood and Dallas introduced continuous flow inspection lines for airframes and engine mounts, while Pratt & Whitney engineers refined the R2800 engine's cooling baffles to handle sustained high-altitude throttle settings. Maintenance specialists stationed in England reworked these improvements into field kits that could be installed rapidly between missions, ensuring fighters stayed airborne longer and flew hotter without mechanical failure. German intelligence summaries acknowledged the astonishing tempo of American mechanical output, but underestimated the cascading effect it had on pilot effectiveness. These advantages converged during the Battle of Oschersleben on January 11, 1944, when American pilots demonstrated a combination of range, coordination, and tactical boldness Germany had not prepared for. At dawn, B-17 and B-24 groups lifted off from English fields glazed with frost, engines sending tremors across the runways. Their destination lay deep inside central Germany, where factories producing critical aircraft components waited beneath a low, steel-gray sky. Luftwaffe controllers, relying on the same operational assumptions that had guided them for months, expected to exploit the moment when escorts peeled away. But internal observations compiled later by American group commanders showed that pilots now flew with confidence built on extended range planning and fuel-saving techniques pioneered during training flights over the American West. A composite German controller's recollection, assembled from post-war files, described disbelief spreading across his command room as radar operators tracked escorts far beyond the expected withdrawal point. Instead of fading, the fighter screen thickened. Tactical accounts filed that afternoon by American group leaders described P-51s diving in disciplined pairs, using energy retention strategies emphasized in stateside manuals, slashing through intercepting waves of Bf-109s. The narrative of supposedly unskilled American pilots collapsed as Luftwaffe formations broke under the relentless timing and precision of the attacks. Weather worsened as the strike force neared Oschersleben, and drifting snow softened the horizon into a pale haze. German fighters rose again, this time in desperate clusters led by veterans who had fought since 1940. These men recognized the danger immediately. Their adversaries moved with practiced unity, trading altitude for speed along calculated arcs that mirrored diagrams included in tactical bulletins circulated among American fighter groups. The Luftwaffe's expectation that American pilots would respond rigidly or panic under pressure dissolved as P-51s maneuvered with sharp, almost instinctive transitions between climb and dive. Mission summaries written by German flight leaders recorded rare admissions of tactical surprise. When the bombers finally released their payloads over Oschersleben, the sky had become a crucible of fire and metal. Anti-aircraft bursts punched holes through the clouds. Fighters twisted in deadly spirals, engines screaming as they clawed for advantage. Yet through the storm, the coordination persisted. After-action analyses later compiled by American intelligence teams cited this cohesion as the decisive factor, echoing observations first made in pre-war engineering conferences that emphasized human-machine synergy. Engineers responsible for gunsight calibration, oxygen flow stability, and cockpit layout, names often lost behind the roar of combat, had shaped an environment where pilots could push their aircraft to precision levels rarely seen in earlier years. Casualties were heavy on both sides, but for Germany the implications ran deeper than the immediate losses. In operational reports hurriedly drafted that evening, Luftwaffe officers expressed alarm at the precision of the escorts, their extended endurance, and the resilience of bomber formations under sustained attack. The belief that American pilots relied solely on overwhelming force now appeared untenable. Their skill, shaped by simulation, engineering feedback, and rigorous field adaptation, had revealed a fighting force more advanced than propaganda had ever allowed German planners to imagine. By the end of that brutal day, the hidden advantage was no longer hidden at all. Germany had been fighting an enemy whose capabilities evolved faster than the Luftwaffe could react. And as the shock settled, one realization loomed across command posts from Brunswick to Berlin: the worst consequences of this miscalculation were still coming. The coming months would expose those consequences with clarity. In the months that followed the turning point in early 1944, the advantage revealed in the skies over Oschersleben began altering the entire course of the European air war. What German commanders first dismissed as an anomaly soon became a pattern repeated across France, the Low Countries, and deep into the industrial heart of the Reich. The psychological impact was immediate. Luftwaffe pilots returning from missions reported a growing sense of inevitability, an impression that their enemy now operated with a level of coordination and discipline that could no longer be explained away by propaganda. Flight logs from surviving German squadrons recorded the same unsettling observation. American pilots who once seemed inexperienced now maneuvered with precision sharpened by constant refinement, supported by machines that rarely failed and formations that rarely broke. Strategically, the shift was devastating for Germany. Once escorts could remain with bombers for the full duration of deep strikes, factories producing ball bearings, fuel components, and aircraft parts faced relentless pressure. Engineers at Allied planning boards calculated that sustained raids would erode German industrial capacity faster than ground campaigns alone could achieve. German analysts confirmed this grim reality in reports noting that repair crews struggled to restore production after repeated bombardments. Facilities once considered too distant to target reliably, plants at Regensburg, Schweinfurt, and Gotha, found themselves under constant threat. The Luftwaffe's diminishing fighter presence could not compensate for escalating losses in machinery, transport links, and trained personnel. These cumulative blows hollowed out the Reich's ability to sustain meaningful resistance in the air. The psychological consequences inside the Luftwaffe ran deeper still. Post-war interrogation summaries recorded pilots who described the shock of facing adversaries whose tactics evolved between missions. Every encounter revealed another layer of American coordination: steeper dive attacks, more efficient fuel use, tighter escort integration. Veteran German flight leaders expressed despair in confidential memos, admitting that the pace of their enemy's adaptation felt overwhelming. Many acknowledged that their previous assumptions, shaped by years of propaganda that dismissed American pilots as clumsy or inexperienced, had become dangerously outdated. Once those illusions collapsed, fear took their place, eroding cohesion inside already depleted units. As the air war intensified through the spring and summer of 1944, bomber streams grew increasingly confident in their ability to penetrate defended territory. Briefing rooms in England filled with maps showing escort corridors extending over regions once considered unreachable. The psychological lift this brought to crews was profound. Diaries from American airmen mentioned a rising sense of purpose, the belief that mastery of the skies was no longer aspirational but inevitable. German morale, by contrast, sagged beneath the weight of mounting losses and the knowledge that reinforcements arriving from flight schools lacked the hours and training required to challenge well-coordinated Allied formations. The imbalance widened with every mission. This disparity influenced entire campaigns. In the lead-up to the Normandy invasion, Allied fighters swept across northern France, destroying rail hubs, bridges, and troop concentrations. German commanders complained that their aircraft could barely rise without being intercepted. Escort dominance enabled bombers to strike oil refineries critical to the Reich's fuel supply, amplifying the effects of ground offensives. Internal German assessments described the situation as a tightening noose, driven not simply by superior numbers but by an enemy whose training programs, engineering innovations, and tactical evolution had converged into a lethal, unified whole. By late 1944, the Luftwaffe as a coherent fighting force had been severely weakened. The once proud organization that dominated Europe in 1940 now struggled to field planes capable of challenging Allied formations. Pilots entering combat often had fewer than 100 flight hours, compared to the extensive training American airmen received through coordinated simulation, gunnery, and formation programs. Psychological analyses compiled after the war noted that the fear of sudden interception weighed heavily on German crews, many of whom faced overwhelming odds before they even reached operational altitude. Meanwhile, Allied fighters increased their presence across Germany's shrinking sphere of control, reinforcing the perception that resistance had become futile. The legacy of this transformation extended far beyond the collapse of German air power. Military strategists studying the conflict recognized that the integration of training, engineering, logistics, and adaptation offered a model for future air forces. In the early Cold War, American planners applied these lessons to create doctrines emphasizing networked operations, rapid technological evolution, and pilot proficiency reinforced by advanced simulation. Engineers who had refined oxygen systems, gun sights, and engine reliability during the war became architects of post-war aviation, their innovations forming the backbone of emerging jet-age tactics. The psychological dimension shaped post-war thought as well. Analysts concluded that the collapse of the Luftwaffe demonstrated how morale, perception, and adaptability could decide campaigns. Veteran pilots later recalled that the turning point came not just from machinery, but from the moment German flyers realized their enemy's true capability. The shattering of propaganda-fed assumptions created a psychological break from which the Luftwaffe never recovered. This lesson echoed through decades of military theory, warning future leaders against dismissing adversaries based on ideology rather than evidence. As the war ended in 1945, American pilots carried these lessons forward, honoring the engineers, instructors, and technicians whose unseen work made victory possible. Their legacy endured in every air campaign that followed, a reminder that dominance in the skies is earned through relentless innovation, discipline, and the fusion of human skill with industrial strength. In the words of one veteran pilot preserved in a post-war interview and echoed across generations, victory belonged to those who adapt fastest. The end of the Luftwaffe was not simply a collapse of aircraft and fuel. It was a collapse of belief, a recognition that an adversary once portrayed as untrained had mastered the art of modern air war. In the final months of the conflict, as American fighters roamed freely, German units watched their supply lines erased from above, a daily reminder that superiority now rested on the fusion of engineering precision and pilot discipline. Technicians working on frozen English airfields ensured engines, gun sights, and superchargers remained reliable despite brutal conditions, allowing pilots to operate with confidence even during relentless operations. German crews, facing shortages and delays, recognized that no amount of bravery could counter an enemy whose machines were always ready for battle. This widening gap shaped every engagement in early 1945, reinforcing the lesson that air dominance was built not only in cockpits but also in the workshops that sustained them. It became clear that the fusion of industrial might, evolving tactics, and unwavering training had rewritten the fate of air war.